length of a rectangle. Stop. Let's draw a rectangle. The length is 1 foot longer than twice the width. So if W is my width, the length will be 2W plus 1. The area, that means multiply. If I take my width and my length and I multiply, I should get 78. Sounds like we have our equation here. Do the distribution, 2W squared plus W. I might as well subtract the 78 from each side now, and it looks like it's time to factor. 2 does not go into all three terms, but 2 is a prime number, so I know I'm going to have a 2W and a 1W. 78 is a rather large number to factor. Now I can jump straight to the answer in my head, but let's take a look at all your choices. 1 times 78, 2 times 39, 3 times, oh boy, better think about this one, 26. 4 does not go in, 5 does not go in, 2 and 3 do, so 6 does. That would be 6 times 13. That seems to be the one I'm looking for, because here's a 13, here's a 6, and when I look at my inner and outer, there's a 13 and a 12, and if I went 13 minus 12, I'd be in business. So positive 13 and minus 12. This tells me W equals negative 13 halves. That makes no sense in the geometrical context, so W is going to equal 6 feet. Now find the dimensions. The length will be 2W plus 1. So take the 6, double it to 12, add 1 and get 13. The length will be 13 feet, and there are the dimensions of the rectangle that we're seeking. Factor. Okay, notice there's no equals 0 here. We just want two parentheses as our answer. There is no GCF. This is a trinomial. So I'm going to factor this into x plus 7 times x minus 6. This next problem has two terms in it, and that's usually a clue for the difference of two squares, which does work. C squared plus 1 times c squared minus 1. Don't stop there though, because we can factor further, and we have c squared plus 1 just coming down, and then c plus 1 times c minus 1. In this next problem, we notice that 10 goes into each term, but there's a negative leading coefficient, so we want to factor out the negative 10, leaving u squared minus 3u plus 2, which will factor into u and u. Minus 1 and minus 2 will make that all work. For number 13, we notice we have the difference of two cubes. Y cubed is the cube of y, and 27 is the cube of 3. Now your formula for the difference of two cubes was a minus b times a squared plus ab plus b squared. Hopefully you've got that memorized by now from doing enough practice during the chapter. A minus b is going to turn into y minus 3. A squared will become y squared. We will then have plus the y and the 3, which is 3y, plus b squared, which is 3 squared, which is 9. And there's the factored form, and we never go any further. For number 14, we have the sum of two squares, which is not factorable, so this expression we say is prime. For number 15, there are 4 terms. I do not see a GCF going into all 4 terms. I'm going to try a 2-2 split and see if that works. From the first 2 terms, I can factor out an x squared and be left with 2x plus 1. Now I'd like to have a 2x plus 1 over here also, and it turns out that if I factor out a minus 4, that will make it so. So let's factor out this 2x plus 1. In the first half of the problem, we're left with x squared, and in the second half, minus 4. Now don't stop there saying, yee-hee, I got my 2 parentheses. This is the difference of two squares, and we'll factor further, so we have 2x plus 1 times x plus 2 times x minus 2 as the factorization. For number 16, we look for a GCF. I notice the variables are different, but a 3 can be factored out. So I'm going to have 3 times a squared plus 9ab plus 18b squared. Maybe this will go further. Let's see. If it factors, it would have to have an a at the beginning of each parentheses. I happen to know that 3 times 6 is 18 and 3 plus 6 is 9. So plus 3b and plus 6b will give us our final factorization. On number 17, even though it's factored on the left, it's not set equal to 0. So I need to set it equal to 0, and I'm going to FOIL the left side together. I get x squared plus 5x minus 2x minus 10 is equal to 44. I will combine these middle terms, giving me x squared plus 3x, and while I'm at it, I'm going to subtract the 44 on each side to have minus 54 is equal to 0. Now I happen to know that 6 times 9 is 54, so when I go to factor this, I'm going to use 6 and 9 there, and I want these to add up to 3, so I need a positive 9 and a negative 6. So my solutions will be 6 and negative 9 for this problem.